This is a review of the important topics from Algebra 1 that you're going to need to be as successful as possible in Geometry Honors. What I did is I took a few problems off of the Are You Ready for Geometry Honors worksheet, review worksheet, and just kind of did them, and I'm going to talk about the specific tips and tricks that you're going to need to be successful with problems of these types. So first is number 8 on your sheet, and this is a question that involves fractions. And basically what I want you to remember as far as fractions are concerned is when there are fractions, you multiply by the LCD to get rid of them. LCD is the least common denominator. So when you see certain fractions, in this case I only see 2/3 and 1/3. When I want to get rid of these fractions, I multiply both equations completely by the least common denominator. Well, in this case, that's easy. That's simply just 3. So what I do is I multiply both sides by 3. Okay, in doing this, you distribute the 3, and what will happen is when you multiply a fraction by its least common denominator, or two fractions by the least common denominator, what's going to happen typically is you're going to be able to get rid of the denominators. In this case, it's very simple. The denominators simply cancel out, so I get 2n plus 24. Distribute here. This is just going to cancel as well, and that's just going to give me 1n minus 3 times -2, which is 6. So at this point, I'm ready to just to solve. I don't even need a calculator, and in fact, this worksheet requires that you do not use calculator, so I will subtract the n over. So this gives me n plus 24 equals -6, and then the last step is to subtract 24. The final answer is n equals -30. If you wanted to see if that was the correct answer, you could go ahead and plug that back in, but for the sake of this video, you can just watch the steps and see how to do it. All right, the next problem is a system, okay? The first tip I'm going to give you is anytime you see two equations with two variables, you want to rewrite the system in a way that is familiar to you, okay? And that is as pictured to the right here. So that's the first step, okay? So when we do geometry problems, typically you're going to come up with two equations. Sometimes they're going to be next to each other, and that's why these problems look like this. It's because when we do geometry, our equations don't always look like that, okay? Sometimes they look like the way it looks for number 3. So what we're going to do here first is to rewrite the system one equation on top of the other. Okay, so when doing that, now you can see exactly what, it lends itself to things that we're more familiar with. Okay, so this one is going to be elimination. Elimination is when you multiply one or both equations by some number that will allow you to cancel one variable by adding the equations together. So when we look at this, I see if I multiply the bottom equation by -3, then I see that that's going to allow me to cancel out the x's. If you're like, I want to cancel out the y's, you can do that. It's going to be a little more difficult, but it's still definitely doable. The one thing that you need to remember when you multiply an equation by a number, so first I'm just going to rewrite the top equation because I did not multiply the top equation by anything. Just make that neat. Is I distribute to every single thing within the parenthesis, okay, even that constant on the other side of the equal sign. So I'm going to take -3 times 2x is -6x, -3 times -3 is +9y, and then -3 times 7 is -21, okay? Now I can add the equations. When I do that, the x's cancel, and that's the goal of elimination, is to eliminate the variables. That's why it's called elimination. 7y plus 9y is 16y, and 5 plus -21 is -16. So when I do that, I can divide by 16 and get -1. So there's 1/2 of my answer. The last step involved here is to substitute back to find the other solutions. Well, I know that a system has two solutions. It has an x value and a y value. All right, it's not always x and y. It could be, u and v. It could be whatever the two variables are. Regardless, there always should be two. So when I see that y equals -1, I can go back into either equation and solve for x. So I'm going to go into this one. It just looks a little easier. The numbers are a little bit smaller. And yeah, and you pick either one. It's not going to make a difference. So I'm going to write it out. 2x minus 3y equals 7. And what I see at this point is I can take and I can substitute y is -1 in for y. And then doing so, I get 2x equals 4. Extend page. I divide by 2. And x is 2. So I get my two solutions. X is 2 and y is -1. If you want to write it as an xy coordinate to -1, that works as well. Okay, so your answer is x is 2, y is -1, or the point to -1, because the solution to a system is essentially the intersection point between two linear graphs. And if that doesn't make sense to you, just know that there are two solutions, if that is the point. All right, the next thing is quadratic equations. So quadratic equations can be solved one of two ways. The first is it's called MAF. So the first step always, when I see m squared, m, and a constant, is to get everything on one side equal to 0. So what I got to do is I got to pull this 24 over. So the very first step is a very basic step, but it is an important one nonetheless, is to get everything on one side, because you can't do a quadratic equation. You can't do MAF without getting everything on one side. So that's my first step. The next thing is to take M, A, and F. And everything we do at HF starts there. Okay, what you do beyond that is a matter of what you were taught in Algebra 1. I'll show you a couple different methods of getting the answer from the point of MAF, but you always start with MAF. M is the multiplication of A and C. In this case, A is 2 and C is negative 24. You multiply those numbers together, you get negative 48. Okay? A is the B value in this case, simply just 13. And now F is really the only part that you need to think at, because beyond that, it's just processes and doing the same thing over and over. But F is the factors of M that add to A. So I'm thinking about what multiplies to negative 48 and adds to 13. And lucky for me, I know that's 16 and negative 3. If that's difficult for you, make a factor tree. Okay, negative 48. What multiplies to make negative 48? Well, negative 1 and 48. And what you want to find is what these add to. Well, negative 1 plus 48 is 47. So I know that's not 13. And negative 2 and 24. Well, you could add those. That's 22. Negative 3 and 16. Right there, I see it's 13. I've already got it. So if you had trouble finding negative 3 and 16, make a factor tree. Find the things that multiply to make negative 48. All right, from this point, there are two methods to use. Okay, the first method is the one that I personally prefer. I find it to be the shortest. If you just remember the process from this point, it makes your life a little bit easier. But what this method entails is taking the two numbers and then putting in parentheses. The trick to remember is the lead coefficient. So all I did was I just took the F values, and I said m plus 16 and m minus 3. So what I got to remember is that I got a lead coefficient of 2. So what I have to do is I have to divide both of those things by 2. Okay. From here, if it's reducible, you reduce it. If it's not reducible, like negative 3 over 2 is not reducible, you move the number in front. Okay. So what this becomes is 2m minus 3. So it's m plus 8 times 2m minus 3. And now if I'm solving this equation, I just use my zero products property, which says if this times this makes 0, then either one or both things have to be 0. It's the only way you can multiply two numbers and get 0. But so either m plus 8 equals 0 or 2m minus 3 equals 0. If m plus 8 equals 0, m equals negative 8, which is one solution. If 2m minus 3 equals 0, then m equals 3 over 2, which is my second solution. Okay, that's the first method. All right, so I'm going to switch colors. I'm actually going to do the second method. The second method uses the same first step. We always do MAF. We always figure out what multiplies, to the first, the lead coefficient, and your constant is your M. Your A is the number with, or your A is your B value of your equation AX squared plus BX plus C, and your F is the factors of M that add to A. So I'm still going to use that, but instead, your teacher might have taught you Punnett squares. Okay, this is another method that teachers at HF will use as well. Punnett squares consist of, you make a square, you put your leading term, which in this particular problem is 2m squared, in the first box. You put your constant in the fourth box, and you use the factors. You use the 16 and the negative 3 to go into the other two boxes. And what you do at this point is you take out greatest common factors, okay? So I look at the rows, and I take out the GCF. So the GCF out of 2m to the second and 16m is 2m. So I pull that out front, okay? The next thing, I look at this row. The GCF, the greatest common factor of negative 3m and negative 24 is a negative 3. So that comes out here. All right, I look at the columns. The GCF, the greatest common factor out of 2m to the second and negative 3m. No numbers come out, but I can take an m out. Okay, and then out of these things, the GCF out of 16m and negative 24, it looks like I take an 8 out, and that's what's left. So I got, what you see is right here, m and 8, which gives me a factor of m plus 8, and I see 2m minus 3. which gives me a factor of 2n minus 3. Well, you see that's going to give me the exact same two answers. So zero products property, I can jump ahead, would give me the same two solutions. So I just went through that. That took a little bit of time, but these are just a refresher of the two actually two different ways that you can use to solve a quadratic equation, just to factor it out. Okay? So hopefully that's helpful. We'll move along to the next thing. The next thing is about radicals. Okay? Some basic rules to just kind of get at before we even try number 10 and number 6 here are adding and subtracting radicals. Okay? I can't add or subtract radicals unless I have like radicals. For instance, 3 root 3 minus 2 root 3 does equal 1 root 3. Okay? You can put a 1 in front, not necessary. However, if you had like 3 root 2 minus 2 root 3, it equals the same thing because you can't do anything there. You can't subtract or add things that do not have the same radical. Multiplying and dividing radicals is a little bit different. Okay? When you multiply radicals, so if I took, say, like 2 root, I would say 3 root 3 and 2 root, the same ones we just did. So how about 3 root 2 times 2 root 3? That might be a bad example, but basically what you do, we'll look at another one in case that one's kind of confusing, but basically what I do is I multiply the parts outside, and I get 6, and then I multiply the parts inside, once again getting 6, but I keep it under the radical. All right, using different numbers. Say we said 4 root 3 times 5 root 7, okay? If I had to multiply those things, I would get 20 because I multiply the 4 and the 5, and then root 21 because I multiply the root 3 and the root 7. It works the same or similar for dividing. I think I'll just move this up. If I had to divide radicals, for instance, if I had to divide like root 20 divided by root 5, well, you can divide radicals. Okay, if I had to divide root 20 divided by root 5, I can divide those and call that root 4, or simply just square root of 4 is 2. So you see that you can divide radicals in the same way that you can multiply them. All right, so we're going to look at a couple problems here, and hopefully you can see some of these properties at play. The first one, I got 3 root 20 times 8 root 5. Well, 3 times 8 is 24. Root 20 times root 5 is root 100. Well, that's kind of nice because square root of 100 is simply 10. And very quickly you can see that without much work you get 240. You just got to know your properties. All right, the next one, I see that I got a couple radicals that are being divided. Okay, without a calculator, it's a little bit tricky. 375 divided by 3. I think mentally, 300 divided by 3 is 100. 75 divided by 3 is 25. So if I took this, I see that it's going to be 11 root 125. Okay, so that's how that breaks down. Root 375 divided by root 3 becomes root 125. So now I got to break this down. Okay, so now I got to use my greatest perfect square that goes in. So when I think perfect squares, I think 4, 9, 16, 25. Where am I getting these numbers? All right, hopefully you're thinking, all you're doing is squaring numbers. Yes, I'm taking 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, and on and on and on. You can keep going, 64, 81, 100, 121. These keep going on and on forever. You keep squaring numbers. So I'm trying to find the biggest one of these, the largest perfect square that goes into 125. So now I know that it's going to be 25, and it'll go in 5 times. So when I break it up to be the perfect square times the number. So this is going to be 11. Square root of 25 is 5. Square root of 5 is going to stay. So now this keeps going. So 11 times 5 root 5 is 55 root 5. And that is your most reduced answer for the radical that was given for number 6. Okay? The last little rule that comes up, and it's going to come up on some of the other problems, not so much on these problems, is when you have a radical in the denominator, for instance, if I have like 3 over root 2. All right, radicals in the denominator are not typically thought to be acceptable in math for whatever reason. So you want to get rid of those by multiplying top and bottom by that radical. What that does, 3 times root 2 is 3 root 2. Root 2 times root 2 is root 4. When you multiply a radical times itself, it's like squaring that radical. And when you square a radical, that is the opposite operation. So what this becomes would be 3 radical 2 over 2. So square root of 4 is 2. So that's another little trick that you're going to need for some of the other problems. All right. All right, moving on. Quadratic formula. So the quadratic formula is shown to the right. And this is what you want to use when you cannot factor. So I always try first. And again, you see y squared, you see y, automatic. You're thinking, yeah, I'm going to get everything on one side. So I'm going to add this y, 8y to both sides. I get 2y squared plus 8y plus 3 equals 0. And I try to factor. And I say, okay, what multiplies to 6 and adds to 8? I do my MAF. I take 2 times 3 and get 6. I say this. I'm like, 2 times 3, no. That adds to 5. 6 and 1 multiply to 6, but that adds to 7. So I see that F can't happen. When this happens, the quadratic formula is required. So what the quadratic formula is, there's a song. I'll sing it. It's a Pop Goes the Weasel song. You may have heard it. You may not have heard it. But it's x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right. Hopefully that wasn't too embarrassing to listen to, but that's just a quick and easy way to remember the quadratic formula for problems in which you cannot factor. So there, anyways, when I look at this equation, I have to remember that all quadratics are of the form ax squared plus bx plus c. So a is the number in front of the variable squared, b is the number in front of the variable, and the constant c is the number that is constant, clearly. So I'm going to take these numbers and put them into the formula. So it's negative b plus or minus the square root, b squared minus 4 times a times c all over 2a. And then what's left after this is just simplifying, okay? So this is what x equals. You're going to get 2 answers. The reason you get 2 answers is because of the plus or minus in your formula. Okay, you're going to get plus or minus, which should give you 2 answers normally. So negative a plus or minus, actually, I'm not going to use my calculator because there's no calculator required. But I take 4 times 2 times 3. That's going to be 24. 4 times 2 is 8. 8 times 3 is 24. All over 4. Negative 8 plus or minus square root of 40 over 4. Negative 8 plus or minus. I got to find the biggest perfect square. I'm still reducing. What's the biggest perfect square that goes into 40? Well, that's 4. And it goes in 10 times. All right. I get negative 8 plus or minus square root of 4 is 2 root 10. Still reducing. At this point is where a lot of people make the reducing mistake. And the reducing mistake a lot of people make is you don't reduce all 3. If you want to reduce, you can't reduce unless you reduce all 3 terms, okay? Negative 8, 2, and 4, okay? If this doesn't look familiar to you, look back at some problems. You could go to YouTube. There's tons of videos about the quadratic formula, surely. So what you notice is that these all have a common factor of 2. So I take a 2 out of negative 8, gives me negative 4. A 2 out of 2 gives me 1. So I'm not even going to write it. I could write a 1, it doesn't matter. And a 2 out of 4 is 2. And that's it. That is my answer. And you see, that is actually 2 solutions, believe it or not. You got a negative 4 plus root 10 over 2 and a negative 4 minus root 10 over 2. So that's a perfect example of the quadratic formula and when you might need it. Okay, I hope these videos were helpful, and I look forward to seeing you in class.